Physics Part 72. How is energy conserved? Physics Part 72. This is called elastic hysteresis. How is energy conserved? The graphs show the strain energy required to deform the rubber. The area under the graph is greater than the work done by the material in returning to its original length. The excess energy represented by the area bounded by the two curves must be energy dissipated within the rubber, showing up as an increase in the temperature, absorbs for mounting oscillating machinery and preventing the vibrations. Being transmitted to the floor, the mechanical energy of the oscillation is converted to the thermal energy in the mounts. Force extension graph for a polymeric material showing elastic hysteresis. Well, we've got the summary for this section. Forces on an object can cause tensile deformation, stretching, or compressive deformation, squashing. An elastic change occurs when an object seems to be to its original shape and size when the load is removed from it. Hooke's law states that for an elastic change, extension is proportional to load. The elastic constant, spring constant, K, is the ratio of force to extension. Strain energy is half into Kx square. Tensile strain is equal to extension divided by original length. Tensile stress is equal to force divided by cross-sectional area. Young modulus is equal to stress over strain. The ductile and brittle material have characteristic force extension graphs. Polymeric materials such as rubber typically show elastic hysteresis. We've got questions for this section. A spring has an extended length of 12.4 centimeter. When a load of 4.5 Newton is suspended from the spring, its length becomes 13.3 centimeter. Calculate the elastic constant of the spring. The length of the spring for a load of 3.5 Newton. 2. The elastic cord of a catapult has an elastic constant of 700 Newton per meter. Calculate the energy stored in the elastic cord when it is extended by 15 centimeter. 2 wires each have length 1.8 meter and a diameter of 1.2 millimeter. One wire has a Young modulus of 1.1 into 10 part raised to 11 Pa, and the other has got a 2.2 into 10 part raised to 11 Pa. One end of each wire is attached to the same fixed point, and the other end of each wire is attached to the same load of 75 Newton, so that each has the same extension, assuming that the elastic limit of the wires is not exceeded. Calculate the extensions of the wires. Number 4, distinguish between ductile and brittle materials, making reference to the force extension graph for each type of the material. Name an example of each type. Explain what is meant by elastic hysteresis. Thermal heat energy. Well, at the end of this section, you should be able to use the concept of specific heat capacity and identify main principles of the determination of electrical methods. You should be able to define and use the concept of specific latent heat, identify the main principles of its determination by electrical methods. In this section, we will be looking at the effect of heating on temperature, specific heat capacity,